Okay, this is 8G1, 8th grade Geometry Standard 1, Video 2. We are talking about reflections and symmetry today. Here are a few terms to know. I'd like you to write these down in your journal and put some definitions to those. Okay, a reflection is a transformation in which a figure is reflected or flipped in a line. That means over a line or in a line, called the line of reflection. And we have a new coordinate notation rule, and there's actually two parts to it. Sometimes you're going to be reflecting a polygon or a line segment over the y-axis, and you can also reflect a line segment or polygon over the x-axis. And then you're going to see on the last problem I have set up for you that you can actually change that line of reflection. Instead of being an axis, we can move it along to one of the other grid lines, and we'll see that in a few minutes. Okay, first one, find the coordinates of the vertices of the image after a reflection in the y-axis. That means we're going to take this triangle and flip it over the y-axis. So I'll label that axis as being the vertical line. And if we use the notation rule, the coordinate notation rule, I would have the ordered pairs listed, and then I would just follow the rule of that particular case in which we are reflecting over the y-axis. So let's quickly graph these ordered pairs. So A is going to be -2, +4. B is -6, +1. And C is -2, +1. Now, if I'm following my coordinate notation rule of the flip over the y-axis, my primes according to the notation rule, if I go back a page, if I'm flipping over the y-axis, my y-coordinate will stay the same, and the x-coordinate will be the opposite of what it is currently. So if my y value, I'm flipping over the y-axis, my y values stay the same. So I'll have 4, +1, +1. And then the negative x in this notation rule means whatever my x is, this negative will change it to the opposite because you're multiplying by -1. So the opposite of -2 is 2. The opposite of -6 is 6. And the opposite of -2 is 2. Now you can go and graph those ordered pairs and take out your straight edge and draw your line segments and create your new triangle. Or I'm going to show you a second way that if you have this picture on a grid, you don't even need to do the notation rule. And I'll show you how to do that here. So let's take A first. If I'm going to reflect it over the y-axis, I will count the units away from that axis, 1, 2, and then go the exact same distance on the opposite side, 1, 2, and I have my A prime. My B prime will be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 units away, and we call that B prime. And then the C prime, this vertex is 2 units away from the y-axis, so we go 1, 2 units away, and we have our C prime. All right, now let's draw that triangle. I'm going to cheat here a little bit and use a pre-made triangle and just change its vertex for you. Okay. And what I'd like you to do is match up our coordinate notation ordered pairs and see if it matches my quick way of doing it, just counting the units away from your line of reflection. Let's just take one in particular. So A prime, if I did my notation correctly, should be at 2, 4. Let's check it. 1, 2, yes. 1, 2, 3, 4, and it checks, okay? So all three of those will check out, and we have our reflection in the y-axis. Okay, the next one says, find the coordinates of the vertices of the image after a reflection in the x-axis. So if I were to go and use my coordinate notation rule, I'll go back, it says right here, when I reflect in the x-axis, my x will stay the same, but I'll take the opposite of my y values. I personally right now have the picture staring at me, so I'm going to be counting the units. And I have, remember, this is the x-axis. I'll label it. There's my x-axis, and I'm reflecting over it, so I have my A being 1 unit from the x-axis, so I'll go 1 unit in the other direction and call that A prime. B is also 1 unit away, so I'll count up. So I have B prime, and C is 1, 2, 3, 1, 2, 3 units, C prime. We'll grab a polygon. And you'll be using a ruler or straight edge for that. And we have a reflection, a mirror image in the x-axis. Okay, last one. The difficulty level has risen here a little bit. We are no longer reflecting over an axis. We are reflecting over a certain grid line, and in this case, they have this pink line. You see this pink dotted line? They call this line x is equal to 3. Now let me talk a little bit about why that is. Why is that x equals 3? If I were to create a table and just pick some random values on this line, I'm going to put a big dot here. So these are points on my line. I'm just going to take a few of them. And let's talk about what those grid lines mean, or I'm sorry, what those ordered pairs are. So if I count over from the origin, like I always do, I have 1, 2, 3. So 3 is my x, and I go up 1, 2, 3, 4, 5 to get to my point. There's one ordered pair on my line called x equals 3. Let's take this ordered pair, 1, 2, 3, and then I go up 1, 2 on my y coordinate. And then let's just take this one down below the x-axis. We go ordered pair 1, 2, 3 again, and then I go down 1, 2, 3 to get the y coordinate. And what do you notice about all of my x values? Yes, all of my x values are equal to 3. So that's why they call it the line x equals 3. Now, if I'm going to reflect over that, we're going to have the same idea that we used in the previous screens. And let's just take a look at that figure. We have B being 2 units away from my x equals 3 line. That's my line of reflection. So then I must be 2 units away from my B prime. Let's check the other ones. C is 1 unit away, so I have 1 unit away on the right side of it, and we have C prime. And then the A, make sure you're not counting to the y-axis, we're counting to the line of reflection, so we go 1, 2, 3, 4, so we go 4 away. 1, 2, 3, 4. So we have just reflected over the x equals 3 line, but in the directions it says, how about we draw this image of triangle ABC as a reflection in the x equals 5 line. Okay, so that means I need to move my pink dotted line, which was at x equals 3, to the x equals 5 grid line. So I'm going to go to my 0. I'll go 1, 2, 3. That's where I was. They want me to go to x equals 5. So 4, 5. There is my new line of reflection, and they would like me to take my triangle ABC and reflect it over my x equals 5 line. All right, so it's the same process, nothing different here. We're going to count the B, 1, 2, 3, 4, so 1, 2, 3, 4, label it B prime. And then we have, let's go to the C, so 1, 2, 3 away, 1, 2, 3 away. We have C prime. And then the A is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and that is A prime. And we take our figure, and there you have it. We can get rid of those now. So we are now reflected over the x equals 5. You know, the only other thing that you might come across is they take this vertical line and maybe they tilt it so that it's a horizontal line and you need to reflect over the horizontal line. So let's see how that would look. Let me clear some of this off. And let's create that pink line horizontally. So maybe we go like this. And it says reflect over the x equals, what are we at, 1, 2, 3. Reflect over it was the x, so now it becomes the y line. So y is equal to 3, and we have to reflect this figure over the new line of reflection, y equals 3. I could show you that in class. Okay, in your journal, define the given terms on page 2 of the flip chart and write a few sentences on what you think you learned from this video. Any questions, please don't hesitate to ask in class, and we can start hitting some of those higher level application problems. And I'll see you in class.